Good evening, all of you. Whether my slide is visible, I think it is visible at uh, your end also. So may I start with the working principle of laser beam machining? Hello. Hello.
Yes, sir. Yes, sir.
Okay. So I will start now. So last time we were discussing about the laser beam machining, and we have started with the how to produce a laser. That means how that laser we will get from the our light. Sorry, from our that low energy atom. Okay, and then it is conversion while it will come back to its low level energy level. No, that time that emission of protons will happen, and that time again emission will be of two types. One is the stimulated, and second is the instantaneous. Okay, and we are concentrating on only that stimulated emission, and then it's a light amplification. By doing light amplification of this stimulated emission of radiation, we'll get the laser. Okay, that is a full form, because that is this laser is an abbreviation of that light amplification of that stimulated emission of radiation. Correct. And to get that lasers, okay, laser, we are using the light source. Okay, again that light will get from the electric energy. Correct. And that electric energy we are converted to the light, and then for a metal removal purpose we are using the thermal energy of that light. Okay, and for that purpose we are taking the one tube. Inside that tube we are placing that lasing medium, or we can call lasing material. Okay, and by giving the light on that atoms of the lasing material, we are taking that low level atoms of that lasing metal to the high level, and immediately it will come back to the it's a low level energy. Okay, and uh, during that process, or during that step, that atoms will release or emit that proton, or the that simulated emission. Okay, and from again that simulated emission or that laser, we are using some part of that laser for the metal removal purpose. That means using the thermal energy. Okay, so that is the basic idea. So we'll discuss this now. So as we know that energy input is in the form of heat or the electricity or the light. Okay, and it's that we have to into the that lasing medium. Okay, lasing medium is what? That lasing material. Okay, the from that material, the atoms of that, or atom or the molecule of that material. One. Their energy we need to increase. Okay, and for that purpose we are giving the light. Okay, and while coming back to the low level energy, that atom will release the emission. Okay, so here the form of heat or the electricity or the light is given into the lasing medium, and as a input or the source of energy. For what purpose we are giving that energy? For the stimulation, or the stimulate the that atoms of the which are at low level energy level, and by stimulating that atom to the higher level. Okay, for that purpose we are using the source of energy. Okay, so this energy what we are giving, from what to the atom, and then it will goes to the higher level energy. So this energy from that laser medium comes outside as a laser. Okay, आता एनर्जी बाहेर कधी येणार आहे त्या ऍटम पासून? ज्या टायमाला ते हायर एनर्जी लेवल पासून लो लेवल एनर्जीला येत असताना. ओके, सो दॅट energy which is coming out from that laser medium, okay, so that energy will be considered as a laser wave, okay, laser wave, and which is useful for our different activities concerned with the machining activities like drilling, welding, cutting, or the heat treatment or the hardening of the workpiece material and the many things. Okay, आता कळालं. ॲटम लो लेवलचा वर आपल्याला हाय लेवलला न्यायचा असेल तर आपण एक्सटर्नल एनर्जी वापरतोय. ओके, मग ते एनर्जी घ्यायचं कुठनं तर आपण इलेक्ट्रिसिटी किंवा लाईट किंवा हीट, आणि मग तुमचं ते लेझिंग मीडियम मधलं जे लेझिंग ॲटम असणार आहेत म्हणजे मटेरियलचं ॲटम, ते काय होणार, बाहेरचं एक्सटर्नल एनर्जी घेतल्यामुळं वरच्या लेवलला जाणार, वरच्या म्हणजे कुठल्या हायर एनर्जी लेवलला, आणि ते वर गेल्यानंतर पुन्हा लगेच खाली येत असतात. खाली येत असताना काय होणार आहे, ते ॲटम त्याची एनर्जी बाहेर टाकणार, म्हणजे बाहेर काय म्हणजे रिलीज करणार किंवा इमिट करणार. ते म्हणजे काय तर प्रोटॉन असतात, इमिशन, तेच म्हणजे आपलं लेझर. ओके, सो दॅट लेझर वेव्स वी हॅव टू यूज फॉर द डिफरंट मशीनिंग ऍप्लिकेशन. ओके, नाउ कम टू द दिस डायग्राम. Okay, that diagram. So here, if you see in this diagram, there are electrodes are there actually. Okay, at the both end of the tube. आता इथं ट्यूब म्हणजे काय तुम्हाला सांगतो, जे लेझरचं मटेरियल असणार आहे, म्हणजे ज्यापासून आपण ज्याचं एनर्जी लेवल आपण वाढवणार आहे ना, ते मटेरियल म्हणजे लेझर मटेरियल नॉर्मल म्हणतो आपण, किंवा लेझिंग मीडियम पण म्हणतो, ते नॉर्मली आपण त्या लेझर ट्यूब मध्ये ठेवणार आहे. ओके, अँड सो बोथ द साइड ऑफ दॅट tube we have to place the electrolyte actually. Okay, so you can see in that diagram also cathodes are there and the anodes. Okay, because आता मला सांगा, ते लेझर ट्यूब मध्ये जे मटेरियल आहे त्याचं मला एनर्जी लेवल वाढवायचं ना त्या ॲटमचं, म्हणून मला त्याला लाईट द्यायची गरज आहे का नाही, लाईट. हा, मग लाईट द्यायचं असेल तर मला डीसी पॉवर लागणार आहे ना, म्हणून ते पॉवर सप्लाय थ्रू मी काय करणार, धरून झाला की तुम्ही एक बल्ब घेऊ शकता किंवा लॅम्प. ओके, हा, तसं ते कॅथोड असणार आहे. ओके, मग सो हिअर वी हॅव प्लेस्ड द इलेक्ट्रोड्स, ओके, विच आर ऍक्च्युअली प्लेस्ड ऍट द बोथ एंड ऑफ द ट्यूब. ओके, ट्यूबच्या बघा तुम्ही दोन्ही साईडला दिसतात कॅथोड दिसतात. ओके, and in that tube we have to place the lasing material. आता ते लेझरचं मटेरियल मे बी सॉलिड असू शकतं किंवा गॅस असू शकतो. मग डिपेंड ऑन दॅट मटेरियल, लेझिंग मटेरियल, आवर लेझर classified into two types: solid state laser आणि gas laser. Okay, that we are going to see in the next slide. Okay, आता तुम्ही बघू शकता कॅथोड आहे, and then we have the one tube which is filled with the that laser material. Now for which is the whatever I have shown that diagram now, so that is of the gas laser. That here CO2 laser वापरले, so त्या ट्यूब मध्ये तुमचा CO2 गॅस असणार आहे. So your tube is filled up with the gas, maybe your CO2 gas or the carbon monoxide gas or helium gas or the nitrogen gas. Okay, as a lasing gas, as a lasing gas, and it is filled up at a low pressure. It is filled at a low pressure. So again you can see there are two electrodes actually placed. Okay, and that are used to energize the atom and the molecules of that gas. Okay, आपल्याला त्या आतल्या ॲटम जे आहेत कुणाचे तर लेझिंग मटेरियलचं कुठे आहेत, लेझर ट्यूब मध्ये, तर त्याची मला एनर्जी लेवल वाढवायचे म्हणून मी इलेक्ट्रोड्स वापरतो. इलेक्ट्रोड्स म्हणजे काय, माझं ॲनोड अँड कॅथोड, जे डीसी पॉवर सप्लायला मी कनेक्ट केलेत. ओके, आणि जर एनर्जी लेवल आपण ॲटमची त्या मॉलिक्युलची वाढवलं कुणाच्या तर गॅसची, so while coming back to the its original, that means the low energy level la yetana, that will release the photons. Okay, that means the our stimulated emission. Okay, so electrodes are used at both the end of the tube. इथं दोन, ह्या डायग्राम मध्ये मी दोन ट्यूब दाखवल्यात, त्यामुळे दोन्हीकडे पण कॅथोड आहेत, दोन्हीकडे तुम्ही बघू शकता. ओके, then what are the electric current we are supplying now? So that electric current stimulate maybe that lasing medium, okay, or that gas atoms or the molecules which are present in that tube. Okay, stimulate म्हणजे काय, वरच्या लेवलला म्हणजे हाय एनर्जी लेवलला ते नेणार. Okay, and simultaneously while coming back to its low level, it is going to release the or emit the that's laser. Okay, so feedback system here we have to use. So feedback system already yes, last lecture we have seen. So feedback system consists of the parallel mirrors. Okay, you can see parallel mirrors of आहेत बघा मिरर. ओके, दोन वापरल्यात, एक आउटपुट मिरर आणि एक टर्निंग मिरर आहे बघा. ओके ओके, so here feedback mechanism, it is consist of parallel mirrors at a end of the tube. So at both end of your tube we have placed that one side output mirror and the second end la turning mirror ठेवले. Okay, so that one mirror is fully reflective and okay, one mirror is the fully reflective and another mirror is the partially transparent which gives the laser output. Okay, and I repeat, जो एक लेझर एक मिरर आहे त्या दोन्ही पैकी तो एक आहे तो फुल्ली रिफ्लेक्टिव्ह असणार आहे आणि अदर मिरर जो असणार आहे तो पार्शियली ट्रान्सपरंट असणार आहे, विच गिव्स द लेझर आउटपुट. मला जे मशीनिंग कटिंग करायसाठी जे लागणार आहे मशीनिंगसाठी ते लेझर आउटपुट कुठनं मला भेटणार, तर partially transparent mirror पासून. Okay, so here you can see in this diagram whatever that output mirror is there now, so which is I have shown that, and the partially transparent, that whatever the output mirror is there no, so that is a partially transparent, which is partially transparent म्हणजे काय, आउटपुट मिरर पासूनच मला लेझर बीम भेटणार आहे ते. ओके, सो प्लीज note this. So through this partially transparent or we can call output mirror lasing, that means protons actually coming outside as a lasing medium. Okay, as a laser protons. Okay, which will coming outside from that mirror. But this mirror, okay, these are actually highly reflective mirrors. Okay, so sorry, that whatever the turning mirrors I have shown, no, so that are highly reflective mirrors. Okay, so you can see here two tubes or two pipes are used. So when protons are actually coming outside from that pipe, no, okay, from that your tube, okay, so it will reflect here that on the your output mirror, and then again it will reflect at another mirror also. Okay, in this mirror, and then it will come inside the first chamber. Okay, पहिल्या चेंबर मध्ये येणार, and then it will transmit through this partially transparent mirror. Okay, पहिल्यांदा जे प्रोटॉन बाहेर पडतात त्या ट्यूब किंवा ह्यातून ती काय होणार, तुमच्या जे हे आहेत रिफ्लेक्टिव्ह हायली रिफ्लेक्टिव्ह मिरर जे आहे म्हणजे टर्निंग मिरर, तिथं पहिल्यांदा रिफ्लेक्ट जाणार आणि तिथनं पुन्हा रिफ्लेक्ट होऊन तुमच्या ट्यूब मध्ये येणार आणि तिथनं पुन्हा अजून तुमचे इट विल कम फ्रॉम दॅट फर्स्ट चेंबर as a laser. Okay, so I repeat, when your protons are actually coming outside from the your tube, no, then it will reflected. Okay, and again it will reflected with the help of that turning mirror, then it will again reflect in that mirror, and then it will come inside that first chamber and it may transmit through this your output mirror, that means partially transparent mirror. Okay, but here whatever this highly reflective mirrors, when this proton is coming outside from the highly reflective mirror, no, because of that highly reflective mirror, so it will come inside after reflection also from that highly reflective mirror, so again it is coming inside. Okay, now to redirect that proton which are come back again, no, into that lasing medium, so for that CO2 laser or gas laser, this kind of folded or resonator axial flow CO2 gas. Okay, for this folded resonator axle CO2 flow CO2 laser. For that purpose, normally these turning mirrors are used. Okay, and here for generating 100 watt of the laser power, no, certain length of the tube is required. Okay, आता जर मला ज्या लेझरचं पॉवर 10 वॅट जर पाहिजे, सॉरी 100 वॅट पाहिजे असेल तर काय करणार, लेंथ मला जास्त गरज असणार आहे. ओके, त्या गॅस ट्यूबची किंवा लेझर ट्यूब ची. So when we need a huge power, no, so we need a high longer pipe. So this longer or very long pipe we cannot make inside the lab. So this kind of small pipe. आता बघा मला गरज होती मोठी पाईप, पण मी काय केलं, तीच पाईप काय केलं किंवा ती ट्यूब मी दोन केल्या इथं दिसतंय ना, ह्या डायग्राममध्ये दोन ट्यूब आहेत. ओके, so we can keep like this in lab also for the experiment purpose, also for machining. Okay, so that from every pipe, okay, you can, for every pipe you can use this kind of turning mirrors can be used. Okay, whatever I have shown, no, that. So this proton, after getting outside, no, when it comes outside from that your that chamber, okay, then we can use that from whatever lasers we are getting from that output mirror, no, that we have to use for the machining or the drilling. ओके, आता ते जे आउटपुट मिरर पाशी बांध दाखवलं ना, ती झालं तुमचं लेझर बीम. ओके, आणि त्या लेझर बीमच्या पुढे तुम्ही लेन्स वापरायचे. ओके, फोकस्ड लेन्स, आणि तिथनं मग तुम्ही तुमच्या वर्कपीसवर ते पास करू शकता. ओके, आता समजलंय का, मागच्या वेळेपेक्षा आता समजलंय का? हा, आता ह्या डायग्राम मध्ये बघा. ओके, जे बीम मला जी भेटलाय ना, हॅलो ऐकू येते ना, हा, जे बीम मला आता जी भेटला ना, तो कुठून आलता, तर आउटपुट मिरर पासून आलेला आहे बघा. ओके, so that beam, laser beam, we have to pass through that focusing lens so that it can concentrate on the small localized area of your workpiece, and from that localized area you can remove the material with the by that heat energy of that your beam. Okay, so due to that heat, melting, localized melting and the vaporization will happen on that your workpiece, and from that your workpiece material will be removed. Okay, आता idea clear झाले? I know last lecture there were some confusion because we were gone for at the basic, that means in the physics, पण आता आपलं मशीनिंगचा पार्ट चालू झाला. आता समजलं? प्लीज से येस और नो, प्लीज.
येस सर.
चॅट बॉक्स मध्ये एक दोन जण तर म्हणा येस. मी तुम्हाला बेसिक पासून सांगितलं लेझर कसं बनवलं जात आहे. ओके, लाईट पासून, म्हणजे लाईट म्हणजे आपली इलेक्ट्रिक एनर्जी. ते तर मी काय करतोय, लाईट म्हणजे आपलं जे लॅम्प किंवा जे असतं ना, ती देऊन आपण काय करतोय, त्या लेझिंग ट्यूब मध्ये जे लेझिंग मटेरियल असतं ना, त्याला आपण काय करतोय, स्टिम्युलेट करतोय, आणि त्यापासून आपल्याला ही भेटणार आहे लेझर, आणि ते लेझर बीम आपण कटिंग साठी वापरतोय. ओके, अँड दॅट यू हॅव टू पास थ्रू दॅट फोकसिंग लेन्स. ओके, हा, धनश्री सोनवणे, हॅव गॉट द पॉइंट. वैभव सॉरी वैशाली मोरे, समृद्धी देशपांडे, सुमित पटवारी, ओंकार काळे, बागुळ, वाडेकर, हॅव गॉट नाव कन्सेप्ट. मी का मुद्दाम तुम्हाला ते मागच्या लेक्चरला लेझरचं वर सांगितलंय, तर नॉर्मली ते कुठल्या बुक मध्ये जर तुम्ही टेक्स्ट बुक वापरला तर काय ना, नॉर्मली सांगते वन लाईन, लेझरचा यूज करून मटेरियल रिमूव्ह केलं जातं, आणि ते मटेरियल कुठल्या ऍक्शन होतंय, तर मेल्टिंग आणि वेपरायझेशन म्हणते. ओके, पण ते लेझर कुठनं तयार होतंय ते आपल्याला कळलं पाहिजे ना. आपण नक्कीच म्हणायचं की इलेक्ट्रिकल एनर्जी बेस्ड इलेक्ट्रो थर्मल एनर्जी बेस्ड ही प्रोसेस आहे, पण ती इलेक्ट्रो एनर्जी आपण कशी वापरतोय, त्याचे कन्व्हर्जन लाईट मध्ये कसं होतंय, त्या लाईटचं पुन्हा आपल्याला थर्मल म्हणजे हिट मध्ये कसं रूपांतर होतंय. सो दिस इज टोटल एंटायर प्रोसेस. आता समजलं? आता अजून मी म्हणतोय, जे लेझिंग मिडियम असणार आहे, जे ट्यूब ओके, लेझिंग ट्यूब, त्याच्यामध्ये लेझर मटेरियल आपल्याला टाकायचं आहे. आता लेझर मटेरियल कुठलं कुठलं टाकू शकतो त्याच्यानुसार तुमच्या लेझरचा प्रकार आहेत. CO2 लेझर म्हणतो आपण, ओके, ND ॲग म्हणून आहे. ओके, आता ते मी दाखवणार तुम्हाला, सॉलिड स्टेट लेझर वेगळे आणि गॅस लेझर वेगळे. ओके, नाव कम टू द नेक्स्ट स्लाइड. आता वर्किंग प्रिन्सिपल समजलं. लेट अस डिस्कस द सम characteristics of this laser. Okay, so actually this laser light is there, no, it is monochromatic. Okay, so now again question will arise that what is meant by monochromatic. So monochromatic means it's a wavelength occupies a very small region. It's a, I repeat, whatever the laser light we are getting, no, light means what, that laser beam which are getting, no, so it is monochromatic. And monochromatic means what, it's a wavelength occupies very small region, narrow portion of the spectrum it will occupy, so that it is called as monochromatic laser. Okay, so because it's a wavelength occupies at a small or narrow portion of your spectrum, so that it is we can focus or our this whatever our laser light or laser beam is there, no, so that can be focused into very small area, because it's a wavelength lies into very small narrow region. Okay, so for that purpose, simple lens we can or can be used to focus and concentrate that your laser light into the very small area or very small diameter. And because of this, high intensity laser beam can be generated. Okay, जे मोठं साधं सिंपल आहे ना, धरून चाला की 10 इंचच्या पाईप मधून तुमचं वॉटर चाललंय आणि तेवढंच वॉटर, मी काय म्हणतोय, तेवढंच फ्लोर जे आहे मास फ्लो रेट किंवा जे व्हॉल्यूम आहे, सॉरी, व्हॉल्यूम ऑफ युअर वॉटर, ते जर मी 3 इंचच्या पाईप मधून वॉटर पाठवलं तर काय होणार हो, त्याची इंटेन्सिटी, त्याचं फ्लो रेट वाढेल ना एकदम फास्ट जायला. सेम तसंच काय केलं तर फोकस्ड लेन्स मी वापरले आणि त्या फोकस्ड लेन्स मधून माझं काय चाललंय आता, लेझर लाईट चालले किंवा लेझर बीम. त्यामुळे आपल्याला काय भेटू शकतंय, वी आर गेटिंग द हाय इंटेन्सिटी लेझर बीम. ओके, we are getting that, or we can generate through that focus length. So normally whatever the high intensity laser beam, no, so that is normally not possible by other type of light. Other type of light ना आपल्याला तशी high intensity laser beam मिळू शकत नाही. So because of this monochromatic property of this laser, no, it can concentrate or it can be concentrated using the very simple lens, okay, into the very smaller area, so that is that is by high energy beam can be generated, and which is not possible by other kind of light. Okay, now again second characteristic about the laser is that first is monochromatic. Whatever your laser light is there, no, it is monochromatic in or I means a low degree of divergence. This also point is important. Whatever our laser light is there, no, it's having low divergence, low degree of divergence. Now again question arises, what is mean by divergence? Divergence means what? Deflection of your beam per unit length. Okay, deflection of your beam per unit length. Okay, of your that length, traverse length of the laser light. So it has a very low diverse divergence rate, and laser light has a very low divergence rate, so which is responsible for the highlight intensity. Okay, so that is why we use the laser in material processing. Okay, where we require high power density laser. Okay, so this is another characteristic of our laser. Then, as laser beam having the degree of monochromaticity, high degree of coherence, high brightness, high peak power, high energy per pulse, and very small size of focused spot. So that are responsible for the machining of or cutting or drilling, welding, for hardening. Okay, again for heat treatment of material, of any material, we can use this type of laser. Okay, so these are the properties which are responsible for using in different machining operation. Okay, so these are the characteristics or the properties of the laser which are responsible for machining operations in different field. Okay, again if you go for the statistic, no, so whatever the laser is there, no, our, so laser lights wavelength varies in between 0.21 micron to 11 micron. Okay, 0.21 micron to 11 micron. Okay, in between ruby. As now again, this ruby means what? This is the material that I am going to tell in the type of the laser. I repeat, laser lights wavelength, it varies in between 0.21 micron to 11 micron. Okay, in between this range. Again, in that for ruby, uh, this wavelength is as very small, that is 0.70 sorry 0.7 micron. ओके, रुबी ट्यूब इज यूज्ड. मी त्याबद्दल बोलणार आहे पुढच्या स्लाइडला बरं का. Again for NDAG laser, okay, this is again the type. Okay, I am going to discuss this again in this detail. Again for this NDAG, no, this laser wavelength is near about 1 micron, and for our carbon monoxide laser, this wavelength, it goes up to 2.7 micron. Okay, and for CO2, okay, carbon dioxide laser, this laser's wavelength, it has 10.6 micron wavelength. Okay, NDAG म्हणजे काय, कुठलं मटेरियल हो, माहिती आहे का, केमिस्ट्री मध्ये किंवा फिजिक्स मध्ये ऐकलंय का? So NDAG means what? Yeah, this NDAG is the one of the type of laser. So ND means what? Neodymium. Okay, neodymium. Then D stands for doped. Okay, neodymium, doped yttrium. Y stand for yttrium, A for aluminum, and G for garnet. Okay. Okay, for spelling of that NDAG, no, I have just dropped one message. You can check what is the NDAG laser. So N stand for neodymium, doped yttrium, aluminum, garnet. So this is one of the material. This is a crystal, and that we are using, or that is used as a lasing medium for solid state laser. Solid state laser एक प्रकार आहे, ते आपण बघणार आहे इन डिटेल मध्ये. ओके, CO, carbon monoxide, helium, carbon dioxide, that is again gas laser. Okay, so this that laser wavelength is another characteristics. अजून मी रिपीट करतोय, जे स्टॅटिस्टिक जे भेटते आपल्याला ते वेगवेगळ्या रिसर्च पेपर मधून भेटतंय. ओके, कुठल्याच पुस्तकात तुम्हाला व्यवस्थित भेटणार आहे. तुम्ही जर ऍडव्हान्स मशीनिंग प्रोसेस बाय विकेजन बुक जर वापरत असाल तर त्यात त्यांनी सांगितलंय, रेफरन्स सांगितलंय की हे डेटा आपल्याला कुठनं भेटलाय म्हणून. ओके, नाव नेक्स्ट. नाव So to use this laser now for this our machining of your workpiece, so our workpiece should be kept very close to the focal point of the lens. Okay, आता जे लेझर बीम जे बाहेर येतोय आपल्या लेन्स पासून, सो नियर टू दॅट वी हॅव टू प्लेस आवर workpiece. That means our workpiece should be kept very closer to the focal point of the laser. So there are three different elements of this laser device. Okay, जे laser device मगाशी मी दाखवलंय. Okay, once again I will show that. Okay, so it has three important elements. First one is the laser medium. First is the laser medium. I am telling about the three different elements of laser device. One is the your laser medium. Okay, जे डायग्राम मध्ये मी लेझर रेक्टेंगुलर शेप मध्ये दाखवले ते लेझर medium. Okay, that means the collection of the your atoms or the molecules or the ions which generate the protons. And the second element is the pumping energy or the heat source. Okay, which is required to excite our these atoms, okay, into the to excite these atoms into the higher energy level. And the third one is the our optical feedback system. Feedback म्हणजे काय? Reflection. Okay, feedback system means what here? Mirror. So optical feedback system which is used to regenerate these photons into that your laser medium. Okay, so these are the three important elements of our laser device. Okay, so whatever laser beam or whatever our laser beam power density is there, no, so that we can be increased by focusing. Okay, जेवढं तुम्ही फोकस लेन्स जो वापरत असा फोकस्ड लेन्स, so using that we'll get the high density high intensity of your laser beam. Okay, so by focusing, by using the lens, this laser beam power density can be increased. Okay, so due to that we can use this laser beam power density, high power density laser beam to interact with your workpiece. Okay, that means for the welding, heat treatment, marking, and the cutting purposes. Okay, so these are the different operations. So different kinds of operation can be done based on your energy density of laser beam. Okay, so high energy density is required for machining operation. Okay, I repeat, high density of your laser beam, it is required for the machining operation, different machining operations. So now that high density means what? It may be 1.5 into 10 to the power of 6 to 1.5 into 10. Okay, here I have given, you can see in the slide, machining operation requires 1.5 into 10 raised to 6 to 1.5 10 raised to 8 watt per centimeter square. That much power density of your laser beam is required for the machining operation, and we have to keep our workpiece very close to your focus point or the prime focus. Okay, so this much energy is required. Okay, माहित पाहिजे, statistic is important for you. Again, for welding purpose, here again one more statistic I have given. For welding purpose, this power density of your laser beam density, no, laser beam power density, it is lesser than the energy power density which is required for the cutting operation. So for welding operation, we require lower power densities. Again, its range is given 1.5 into 10 raised to 4 to 1.5 10 raised to 5 watt per centimeter square. Okay, now this data, it is important. You will get this data in the Wikigen book, but again that Wikigen book, he has taken the reference of other research papers. Okay, they have mentioned that also. Okay, in 1980s paper he has referred that. Okay, you can see also in the book. Okay, so this characteristic also we should know. Now, whatever the laser beams are there, no, so that laser beam falls on the your workpiece surface. So there are three while one when our laser beam falls on the workpiece, no, then there are three different phenomena occurs. Okay, ज्या टाइमला तुमचं लेझर वर्कपीस सरफेस वर फॉल होतं म्हणजे काय स्ट्राइक होतं त्या टाइमला three different phenomena occurs. So some of the light or laser light it may reflect on the your workpiece. Okay, काय होणार जेवढे लेझर आहे ना त्या लेझर बीम मधले त्यातली लाईट okay some of the laser light it may reflect on the your workpiece surface. So this may be transmitted into the workpiece surface. So transmission of this electromagnetic waves at a ear or workpiece interface, so many things can be happen. Okay, तर ते electromagnetic waves गेले तर so transmission of that electromagnetic waves at a ear, so that interface, so many things can be happen. So reflection and the transmission of this laser light it depends on the reflectivity coefficient and the transmission coefficient of this, or we can call because whatever we are getting that laser, no, we can consider the radiations. So for radiation we know that as like our sun rays we have reflectivity constant, transmission constant, absorption constant. So that reflection and that transmission of the your laser light it depends on the reflectivity constant, transmission constant, and the absorption constant of the your workpiece. I repeat, whatever laser beam which are going to fall on your workpiece, no, so out of that some part of your light is going to reflect and the transmit. Okay, so that reflection and the transmission it depends on the its reflectivity and the absorption coefficient of your workpiece material. Okay, so depending on the intensity of this beam, one of the this phenomena will be occur. Okay, depend on the intensity of the beam, depend on the intensity of the your beam. Okay, that phenomena of will occur. That means a reflection होणार, a transmission होणार, का absorption होणार. So when laser beam power density is low, so in that case no phase change of this workpiece material may happen. When laser beam power density is low, so in that case no phase change will occur, or no phase change of your workpiece material may happen. So there is no phase change of your workpiece material. Okay, so there is no machining may happen. जर तिथं तुमचं लेझर बीमची पॉवर डेन्सिटी कमी असेल तर तिथलं फेज चेंज काय होणार नाही, त्यामुळे मशीनिंग पण होणार नाही. नाउ इफ your laser beam power density is very high, then workpiece surface temperature may rise beyond the melting or boiling temperature, and then it in that case vaporization of your workpiece material will happen, and where your laser falls may happen and machining may carry on carry. ओके, आता कळालं का आपल्याला हाय इंटेन्सिटीचा लेझर बीम लागणार आहे, कारण की ज्या टाइमला हाय इंटेन्सिटी लेझर बीम वर्कपीस सरफेस वर फॉलो होणार आहे, सो दॅट टाइम इट विल राइज द टेम्परेचर ऑफ दॅट सरफेस ऑफ द युअर वर्कपीस, and through that melting and the melting, and then further vaporization of your workpiece material will happen, and through that your machining may carry, machining will happen. Okay, समजलं, समजलं का? ओके, आता समजायला लागलं ना बऱ्यापैकी. मी मुद्दाम तुम्हाला इन डिटेल मध्ये चाललोय बरं का, कळलं? आता आपण जाऊया की लेझरचं कुठलं कुठलं टाईप असतात. ओके, टाइप्स ऑफ द लेझर्स. Okay, so there are different types of lasers are there, like one is the solid state laser and second one is the gas laser. Okay, so either solid state laser or gas laser, okay, so 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 gas laser or and another gas lasers are there. So first we will discuss different आता बघा सॉलिड स्टेट लेझर्स असू शकतात, मग त्यात पण आपल्याकडे टाईप आहेत आणि गॅस लेझरचं पण टाईप आहेत. सो फर्स्टली we will discuss in detail that solid state laser. So like Ruby, ND means काय न्यू डायमियम. ओके, आणि so that is one of the material of the crystal type. And ruby means what? स्टोन वगैरे असतो माहित आहे का? माहित आहे का नाही? रुबी, RUBY, रुबी. एनडी आपल्याला माहित झालं, एनडी पण माहित आहे आपल्याला. रुबी म्हणजे काय? रुबी मटेरियल माहिती आहे का नाही? रुबी मीन्स व्हॉट? इट इज आय हॅव जस्ट सर्च ऑन गुगल. हा, मला बी एवढं डिटेल रुबी मटेरियलचा इन प्रॉपर माहित नव्हतं. मी जस्ट तुम्हाला गुगलवर सांगतोय प्लीज. सो रुबी मीन्स व्हॉट? रुबी इज अ पिंक टू ब्लड रेड colored gemstone is there. Okay, crystal type असतं. Okay, ruby is a pink to blood red colored, pink to blood red colored gemstone. Also variety of the that mineral corundum, that means our aluminum oxide. Okay, so like that this ruby is there. Okay, I repeat, ruby is a crystal type and it's having the pink to blood red color, and it is a gemstone. Okay, it is a gemstone. म्हणजे तुम्हाला ओके. सो नॉर्मली हे क्रिस्टल टाइप मधले येते. क्रिस्टल टाइप मधलं असतं मटेरियल. नॉर्मली आपलं ते गार्नेट वगैरे जे असतात ठोकळं, ते सुद्धा असं पिंकिश कलरच असतात बघा. So that whatever the laser material we are using now, that laser tube किंवा लिव्हिंग ट्यूब टाकणारच मटेरियल टाकतोय. ओके, एनडी मीन्स व्हॉट? once again I repeat, एनडी मीन्स व्हॉट? न्यू डायनेमियम. ओके, न्यू डायमियम म्हणजे एनडी, आणि त्याला ही एनडी ग्लास पण सेपरेट आहे. ओके, अगेन दिस क्रिस्टल, आणि एनडी ग्लास म्हणजे काय ते वेगळं. Okay, so normally for solid state lasers like ruby, NdAg, ND glass, so these are the various kinds of solid state lasers. Okay, ruby laser, NdAg laser, ND glass laser. So these are the three main solid state lasers. Okay, these are the various kinds of solid state lasers. So because of poor thermal properties of this solid state lasers, normally this solid state lasers cannot be used for heavy duty operation or heavy duty application. I repeat, because of poor thermal properties of solid state lasers, we can't use this solid state lasers for heavy duty work. Okay, so this kind of laser will heat up, so it has a poor thermal properties. Okay, so it cannot be used for heavy duty operation. So also this kind of laser, solid state lasers, no, does not operate faster than 1 to 2 hertz, 1 to 2 hertz. Okay, I repeat, this solid state lasers, no, it does not operate faster than 1 to 2 hertz. So it does not occur at faster than this 2 hertz. So this solid state lasers, uh, that means your ND-AG lasers or the Ruby lasers or the ND glass lasers are there, no? So for low pulse application, we can use this. Okay, like spot welding or the drilling operation. Okay, where we need a or we require low pulse. Okay, so for that operation, we can use this. So wherever low pulse operation or we need low pulse, no, that for that application we can use. Okay, because in that case their frequency is less than 1 to 2 hertz only. Okay, so our ND-AG laser, no, that are most powerful in this solid state lasers, and that are normally used for the various operations like cutting. Okay, out of that Ruby laser, ND-AG lasers and ND glass lasers, that ND-AG laser, it is a powerful. Okay, and which is normally used for the operation like cutting operation that वापरू शकतो. So its a main power is there, no, or it's a main power, it is less than the 1000 watt, but which is much more than the our that gas laser, that is a CO2 laser. But here it's a energy density is there, no, it is very high. Okay, here I repeat, NDR lasers having the uh, less mean power. Okay, that is 1000 watt, but that power is much more than the CO2 laser power. Okay, got it? So normally this NDR laser, it is employed for this light work purpose. Okay, again sodium fluoride crystal doped, sodium fluoride crystals which are doped with the neodymium. Okay, that means Ca plus F2 Nd. Okay, this is one, another solid state laser. So this calcium fluoride, okay, when it is doped with that neodymium material, no, so this round crystal rod with the reflective, that time we'll get the ends which are reflective, no? So that are used normally for the generation of the proton, like in crystal and aluminum, okay, sorry, ruby aluminum, in that case we are using, no, so like that. Okay, okay. uh, I think in this solid state laser, no, we have more points. Okay, so we'll continue this point in the next lecture. Okay, थोडं हेवी होऊन जाईल आज तुम्हाला हे बऱ्यापैकी समजलंय ना तुम्हाला आता आयडियाच राहिले ना लेझर बीमची पूर्ण हॅलो वेदर यू
हाँ
गॉट
यस
द
सर
बेसिक कन्सेप्ट सॉलिड स्टेट मध्ये थोडं समजलं आता वन्स अगेन आय विल स्टार्ट विथ दिस पॉइंट इन नेक्स्ट लेक्चर आणि आपल्या सिलेबस मध्ये हे लेझरचा टाईप वगैरे नाही बरं का आता सिलेबस मध्ये स्पेसिफिक काय असं का दिलेलं आहे पण तुम्हाला माहित पाहिजे म्हणून मी घेतलेलं आहे आणि असं म्हणजे लेझर बीम मशीन शिकतो म्हणल्यानंतर माहित पण पाहिजे आपल्याला की लेझरचं मटेरियल कुठलं असतं आणि मग त्या मटेरियल नुसार त्याला सॉलिड स्टेट लेझर म्हणतात का गॅस लेझर म्हणतात हा प्लीज वेट क्विकली आय विल टेक अटेंडन्स
वो झालाय का
Okay, so here for this today's lecture, here we'll stop. Okay, so thank you all of you. Okay, see you in the next lecture.